And then we can go and go to
We're
our
going into
website here.
so resourcedm.com.
Yep. So it's resourcedm.com, and go up here to our FM login. This is where we have some sites set up today.
Hey, Chris. Hey, Chris,
Yeah.
let's back up for just a quick second. Go back
Okay.
to the main page, the main homepage.
No,
So,
this
guys, if you need documentation, we have every documentation on these controllers. You go to resources, documentation, create your login, sign in, and you go to this little search bar right there. And I promise you, you put in PR 650 whatever, enter, and it's gonna bring in all of it. And then you click the most recent guide, try to find the most recent updated version, so on and so forth. So this is a real good tool to have. When RDM first come about, 4 or 5 years ago, I lived in this site. I lived
Yeah.
here. I literally was pulling manuals, reading it. Now, I do reiterate, it is UK English versus USA. So just you kind of got to work with it and kind of put two and two together in certain things. But other than that, get the manuals and read them, and I promise you, it'll lead you a long way.
Yeah, I'm glad you pointed that out. I was going to ask that in a bit, but yeah, the documents are so important. That's why I'm so good at certain like compressors. I've read the manuals from everybody so many times, and it's the same as controllers. And you got to read these documents. You got to put the work in. You do have to read them. And skipping over those steps makes your job longer and harder and frustrating. Because I did that too. I did that too. Just trying to figure it out, and it just doesn't work with controls.
It doesn't work that way. I've been through all these manuals too. That's how I actually kind of learned when I started in this industry, was just face down in manuals, just reading about stuff. And then you go on, do some startups, and everything starts to kind of click together. But and if you do want TDB, it's this resources tab. Go to software. It's right here. It's like the first thing there. So
awesome.
So you can do a lot of things from it. Like you can go to pull reports, and you can like pull alarms across your entire enterprise to see like, how many door open alarms have we had this week, so you can kind of find issues there. But we're going to be using dial site today. And then I'm going to just search. We're going to be going to Lunds and Byerly's Highland Bridge. So technicians are going to be seeing a lot of this view. If you're involved with RDM, a lot of our customers are using this like view of this is layout editor, where you can do a sales floor layout view. So you can have kind of all your cases on a sales floor layout, and you can just go and click and go straight into like an evaporator controller for this dairy cooler here. And you're presented with this little mimic of a walk-in cooler. Or if you were to go back to like a case controller, it shows you like a little case controller.
And so the control technician could build this themselves, or is this done by the OEM?
So these mimics here are actually built into the data manager. So if you're using our case controllers, when they log on, if it's a cold room controller, they're automatically assigned this mimic. If it's a case controller, they're automatically assigned a case. I think with third-party case controllers, you could probably manually set it up so it worked the same. But yeah, then you have like real quick summaries of some temperatures. You can really quickly just graph out data and see how things are running. Or you can go and do like a custom kind of selection. If you just wanted to select, maybe a few things at once, you can go over here to the watch tab where you've selected what you want to pull graphs on, and just, if that's not something you want, you can just make it go away, make it go back. The main graph function is up here where it looks like a graph. And this is where you're going to go in and actually like, if you want to pull a week's worth of data or something like that, you actually go and the select date, and you can actually select through a range of dates. So you can pull, like right now, just a week of data, you can pull that fairly quickly. If you wanted to pull a month, it takes a little more time. You can see that was pretty fast. But usually like pulling a week at a time at 5-minute increments it's really quick. It's not that hard to do at all. You can just kind of go and select whatever.
So Cody, for an example, this is a case controller right now we're talking about. What would be the top 3 or 4 things you would look for when you're going to check a case controller if it's running properly? What would be the things you would want to put on the graph to troubleshoot?
Well, this is an FTE system, so it's a flooded evaporator. It's got offsets in it, so you got to kind of pay attention to that. But regular cases and so on and so forth, first things I'm going to look at is suction, superheat, suction line temperature, superheat, and basically control temp, supplier, stuff like that. That's the first couple of things I'm going to look at. Pressures, if it's got a remote pressure or transducer, like local temperature transducer, I'm going to want to pull that as well and just kind of see what the rack's doing versus what the case is doing. That's the first things I would start graphing and looking at. But one thing I always reiterate to technicians that, like, I'm training, or, they ask this, that, and the other. Guys, just because the controller says that's what it is, that doesn't mean that's what it is. And this goes for any controller. I've done them all. I've set a complete store up in 2 weeks time with microthermal, setting TXVs. I would set this TXV and then the end case wouldn't be right, so just because a controller you set at 8-degree superheat, that doesn't mean it's 8-degree superheat. Just FYI, put a probe on there, still do your normal techniques that you would do at startup to verify. Because, guys, I've turned cases all the way up to 15 to 18 degrees on the set point on the controller that actually equaled 8 degrees. So you got to pay attention to stuff like that too. Just because a controller says that's what it is doesn't mean that's what it is.
You got to check this stuff, and there's a lot more checking with all these controls and all these sensors and temperature probes. And I like what you brought up there. Do you feel, or have you noticed technicians trying to fix a system issue through the controller as an actual mechanical issue? Have you been noticing that?
I see it a lot.
Yeah, and I've been seeing that more and more too. Guys call me and walk through it. So you cannot troubleshoot a system just through the controller. You have to, just like Cody said there, could be a sensor. It could be a temperature probe. It could be a parameter even. Maybe it is a controller thing, but the chances are, if it was already running for 6 months or a year, it's not the controller. It's usually a mechanical issue that's causing a problem. And this is another thing that I've learned. Like, you have a controller that'll do 3 valves. One controller that'll do 3 valves for a case, for an example. But those different coils may be set up differently. And have you noticed this, Cody? Because I've had guys, they'll just I took the program, I jammed it in all the cases because we know it's on the same rack, we know it's the same suction. But even in that one case, you could have different pressures. Maybe it's a design by the OEM. Maybe the airflow across that coil is different on the one on the end than the one in the middle. So if you just put the exact same parameters in, you might not be getting the most efficient running case. Yeah, have you seen that, Cody, yet?
Yeah, I've seen that several times, and I know Chris Prom will agree with this.
Oh, yeah.
Different sections of the store. You're in the back of the store on these lineup of cases, and you have the same program you have at the front of the cases where the produce are at. Well, you got doors open and closing, you got drafts coming in and out, and you've got all this humidity over here. And then all of a sudden in the back of the store, you don't have all that humidity, and you've got the same set points. And techs always wonder why. Well, my case it's going through defrost, but it's still freezing up. Well, yeah, you kind of got to look at these certain things, and there is settings in the controller that can cause that 100%. Here in a minute, we'll go over that, and we can kind of walk you through some of the settings to look at. I can say foremost, Trevor, closed door frozen food cases. I have noticed that EEV and EEV/T settings on our controller, frozen door glass, closed door, I like to see EEV settings on that. And here's why. I've noticed through testing and through, troubleshooting things, we build a lot of frost with EEV/T settings versus EEV settings on the frozen cases. I'm guessing that's because doors opening and closing, and our EEV/T setting operates off of temperature until it gets to superheat. And then it starts going off of superheat. So if that temperature's way up there, it's going to open that valve wide open and leave it there until it gets close to that superheat. And then it's going to start going off that. So what was happening is we were seeing some frozen food door cases like freezing up and building frost on them and so on and so forth. Well, we switched it to EEV and that problem went away. But there's other animals that you have to worry about when you go to EEV settings. there's also about 6 other settings in there that you need to set to avoid floodback, because you will get it. So,
Okay, so this is a good point. So now you're not controlling the EV by superheat per se. You're controlling it by temperature. Can you explain that? Because I've heard this before. So those people that are new to this, can you just kind of explain that one more time? Because sometimes you're not controlling by superheat, correct? That's what you're saying? You're controlling by EEV or temperature.
So right there, you have an EEV, and then you have an EEVT or EET. That is discharge temperature, and EEV/T is discharge temperature slash superheat. So what it does is it basically takes it off of temperature until it gets to superheat settings, and then it'll revert back to superheat settings. It's kind of does both
Okay.
realms. Well, if your temperature in that case is reading 25 degrees or 30 or 50 degrees, it's going to make that valve wide open until it gets down to it's basically a chart inside the controller is what I've kind of figured out, that it's rate of time versus change and so on and so forth. And until it gets in that bubble again, it's not going to revert back to superheat. It just won't. So you get floodbacks instances, and then you get this instance, and then you get frosting going on, and you just get a lot of things going on. So that's a real important setting on these case controllers.
Yeah, and I love that you point that out because this is different than the way we used to do things.
Yeah.
You know,
For
it's
sure.
different than the way we do it. So just got to understand a new way of doing things. And I've heard this before, and I know James talked about it as well. It's an important feature to understand. And when you're working on these controllers, go and read up about the different one. EEV is for superheat, EET is for temperature, and then EEV is for /T is for temperature and superheat, right? Perfect.
Yep. Yeah.
And then all the algorithms built inside in the controller, so you don't have to mess around with it and go in and messing with the P&IDs or anything. That's already built in.
Yes.
Yeah, you could pretty easily just change this from EEV to EET and let it run for a day and just go back and see like the drastic difference between how they control. I don't think I've seen EEV is used the most. I think I've seen EEV/T used for dual temp bunkers fairly successfully, because maybe your superheat's running higher in medium temp mode, so you want to just control your case temp more so than superheat. But usually EEV works the best. And there's all sorts of settings for, if you run into a superheat issue, closing down your valve with your problem opening time for a certain period of time, that can come into play. Because if you start running low superheat, if you start getting 3, 2, 1 negative degrees, then you're going to want to close that valve and let it, just think about what it's done for a while and let it correct itself.
And so are these controllers, are they learning controllers? So as they run, they'll continue to learn, or how does that work in the back end?
I don't know if there's so much learning. They know what they're supposed to be doing. And you just set them to control to what they're supposed to be doing. I wouldn't say they so much learn things. There are things you can do with TDB to, collect data and then send them commands based on that data. So you could kind of create learning programs that maybe do stuff like that, but inherently it's not really learning.
And the big thing so Cody, if you came into this store and you were going to fine tune it, what are the things that the technician should look for? Because after the store, the first thing the guys want to do is get it up and running, because the store owners are always pressing. We got product here. We're throwing it in now. I don't even have any CO2 in the system yet. You come across this all the time. The guys are saying they're putting product in, and I don't even have the rack's not even started. So they just want to get it up and running, right? For when they come back to do a fine tuning, what are some of the parameters that they should be looking at? I know the control type would be one, but what are some of the things that they should look for to do the fine tuning?
So that response on, response off, you want to look at that. You want to look at superheat reference versus what your probe is actually giving out. See how that's set at 12 degrees, and you know what I mean? So they once probably maybe had that set at 8, 6 or something like that, and then put an actual probe on there and was like, oh wow, we're actually way down in here. So you want to look at superheat. You want to look at your alarm weight and your scroll up just a little bit, Chris. your control weights up here and display weights. So 100's for walk-in coolers and zero's for cases,
Logistic.
right? Yeah, zero's for cases. So you want to look at your weights and make sure that walk-in coolers, because your walk-in coolers is going off your return air, which they call air on, and then air off is supply air. And so on cases, they're running off discharge air, which means air off the coil.
Yep.
So you really want to make sure. So you want to look at that. You want to make sure all your control weight is where it needs to be. Superheat, response on, response off, defrosting. You want to make sure all your defrosting down there is correct per case manufacturer. You know, you want to make sure your defrost number, your defrost start. You want to know if it's remote or if it's on the case itself. 90% of the time, it's going to be on remote, which is going to remote back to the DM panel. So these are just some of the things you want to start looking at. Make sure all that's kind of where it needs to be.
Yeah,
That's
no, that's pretty important stuff. So just back one more time. When you say, explain just the control weight again. And because I know you said 0 is cases, 100 is walk-in boxes, but what does it mean by like the display weight?
So 100% is going to be your return air. 0 is going to be your discharge air, and you could set a weight anywhere in between there. Generally, for a walk-in, they're going to use straight return. For a case, they're going to use straight discharge.
You said that. It didn't comprehend for me. Okay, that makes sense. Return air and this. Okay, great.
And another thing about, like you can see evap select, they're using the remote suction from the rack controller. If this were set to local, that's controlling off your local suction and evap sensors. Not the most accurate, but it's kind of a fail-safe way to control. Usually you'll see this set for trans MA for a milliamp, 4 to 20 milliamp transducer. Sometimes on retrofits, you'll see a voltage because they'll reuse those 0.5 volt to 4.5 volts transducers. Another thing on defrost, if this is set to remote and you don't have your defrost mapped in your defrost timers here, you have to go and actually set up a remote defrost schedule for this case. And when you go to map it to the actual circuit, if it's set to auto, it may not be getting that kind of command to go into defrost. So what you'll see is a missed defrost alarm. It's very, very confusing to people because they go, oh my God, I missed a defrost. What happened? Well, what it actually means is your case controller and the data manager, for whatever reason, were not communicating to each other. So it missed its defrost, but the case controller is smart enough in its settings. If you go back to the settings, there's a setting called, it's called no defrost time, this one right here. So that setting, you generally set, if you have 4 defrosts a day, that's going to be every 6 hours. So on the 7th hour, if you haven't gotten a defrost command, the case controller goes, hey, I'm set for remote defrost. I didn't get a command. I'm going to run a defrost now. And on top of that, I'm going to throw an alarm to say there was a problem. So that's what that means. It doesn't actually mean a defrost didn't happen. It means it missed the command for a defrost, but it just did one right then when it threw the alarm.
So how does that work with hot gas defrost? Same thing? It doesn't matter hot gas or not, because that's a little different when you have electric defrost versus hot gas. So
it could be the same thing. The only difference might be like if you have a defrost header on your rack, that's going to be set up to kind of be controlled off of, if you go into these defrost timer settings, you could select your valve device. So you would select your defrost header device on your rack and then select that valve. So when this remote defrost schedule goes in, it's going to switch that valve. Even if they're not communicating to the case controller, it's going to switch that valve as long as it can communicate to your rack controller. So it should still do its defrost anyway.
But that would be set up anyway. It'll already be that valve would be the main defrost valve would be set up in that controller anyway. So can we jump to, because I know we're even over on time now, can we jump to like the high pressure valve and the flash gas bypass valve? This is the things that really in CO2 is probably the biggest difference between a standard rack and a synthetic HFC rack. And a lot of technicians need more experience on how it's working. So can you give us an idea on this one, on these ones here?
So do we want to just look at some data, or do we want to actually look at how they're set up?
A little bit of both, if that's okay. If you guys got a few
Okay.
more minutes.
Yeah,
Oh,
so
yeah.
in setup, so this rack controller is split into parts. So it's split into suction group, it's
Yep.
gas cooler group, oil control, and then over here you have your IO mapping and general setup. If you go into main board, this is where you're going to set up in your parameters like what kind of universal inputs or outputs you're reading on those actual points on the board. And then in IO mapping, like this is for our medium temp group here, this is where you're actually going to tell the board which input and which output you're using for certain functions. So on a suction group, your first pressure position is always going to be your suction pressure. Your second on a transcritical controller is going to be discharge, and then you have two optional monitoring. You can monitor like your receiver pressure or whatever, and then all your temps, your status inputs for like run proofs, your inverter position, that's going to be like your VFD or your variable speed on your gas cooler, and then your relay positions for your compressors. The only thing that's special about like the gas cooler section setup is going to be it has more inverter positions because it has more valve options that it can control and outputs, and it also has stepper output options for where you assign your stepper outputs.
Okay.
Now, one thing is on our controllers, your flash gas bypass valve is stepper 1, your high pressure valve is stepper 2.
That's
Yep.
good to know.
That has to be done like that, because in the software that's just how it is. So that is, a lot of people don't know that.
Well, you would think, the HPVs first, but stepper 1 is flash gas bypass valve. Stepper 2 is HPV. Okay.
And you can actually, I was going to show here. I can't find it now. In our manual on one of the pages, it tells you which position it's expecting each assignment to be.
Yep.
The transcritical controller is a little less flexible in that it's expecting certain. You can use any input on the board that's for that function, but it's expecting it to be set up in certain ways. So it's really important to know that the super pack, the normal super pack for like HFC refrigerants, is different in that I think your suction and discharge pressures have to be set up a certain way, but pretty much everything else is kind of open.
And like right there, you got max gas pressure. So 1450 PSI would be 100 bar, and min gas pressure. Those are pretty important to set up. Because
Correct.
at that point at 1460, that valve should be 100% open, right?
Correct. So it basically, you have a minimum gas pressure that you want to stay in between, which is going to be transcritical, subcritical, triple critical, all that stuff. So it's the controller's going to pick what phase it's in, what state it's in. So low ambient temperatures, low this, it's probably going to be in subcritical. It's probably not going to get to the transcritical rate. Summertime, it's going to be in that transcritical operation quite a bit. I mean, you're going to see it pop in and out every now and then, whatever. But it's going to maintain here. It's going to maintain but it's going to try to maintain 680 and 1450, and that's where these are very important settings.
Yeah. And that's something to look at. I know I've set up a few controllers where that wasn't set up right, and the high pressure valve was acting up. It was all over the place. Had to readjust that. I think we had it at 1250. We set it up to 1450, all up to 100 bar, and all of a sudden the rack just smoothed it right out.
Oh, so. Yeah. Scroll down, Chris. Scroll down to your flash gas bypass valve, because the settings are kind of the same. Right here. So receiver target, this is where a lot of people get a little confused. I've heard it several times, but this is your flash tank. This is your flash tank value. So we're trying to maintain 520 PSI in that flash tank. So that's what that valve is going to correlate to. Now you can do target above and target below. This site is set to 0 and 0 for a reason. So I'll just explain kind of some things that was going on with this site. Our flash gas valve never really wanted to find its spot. And anytime I would set this at 540, I'd get my flash tank to 540 and it'd do some weird stuff to the high pressure valve. And I was like, that's not right. So then I did the receiver target above and below. it really went out erratic. I mean, the valve would shut down and stay shut down, and the pressure would creep up so fast that it wouldn't open the valve in time, and we just had a lot of things going on. So I said, you know what, we're gonna set those at 0, 0. We're not gonna let it target above and below. It just wants to stay at 520, and that's where we're gonna leave it. I had these set at a certain, I don't know who went in there and changed it. Anyways, it is what it is. These were set at a different thing, but this store is running pretty well. I would say right now it's fine. There's nothing wrong with it. But back to, this is your receiver target. This is your flash tank target. That's what your valve is going to correspond to. Response on and response off times, the same thing. Receiver interlock, GC, make sure, I don't know. I've got different viewpoints on it. Everybody says you want those set to GC. I've had it off. I've seen the rack run a lot better with it off. But either way, there is a command in there that if something happens, it shuts down the valve, and there's some other commands in there that it's going to do. The only thing that I see that on the recent update we had got taken out is there used to be a gas gradient, and you could set up the gas gradient for certain CO2 we're using. So UK used a certain gradient on CO2, like they were using refrigerant grade or bone dry or vice versa. Well, they have different grades of refrigerant that these techs are using. Well, it makes a difference in the background of the software because it has different flow rates and it has different weights to it and so on and so forth. I'm not going to get in boring of that, but it does make a slight difference. And you used to be able to come in here and set those gas gradients for what CO2 you were using. They took that out, but it is what it is.
Yeah, and then receiver min max pressure, very important to understand, because if you were running this as air conditioning, that 600 psi might be a little low, so you'd have to go in and push it up closer to the relief setting. Awesome. Yeah, no, so this is good, and this is what you got to spend some time on. You got to go. You can't just go and just set this up without having the manuals, understanding each one of these parameters does. Very, very important. And then like you got liquid injection there, that's on set points 50F. So it's very important to understand each component, because maybe it doesn't have like some racks won't have liquid injection, for example.
Correct. And so, and I'll just reiterate, the technicians out there, back in the day, it took us 2 weeks to get a store fully started up. It takes me almost 6 weeks to get a store fine-tuned and set up. That's about what it takes me.
There you go. So we got to start talking to the end users about it. So this is one of the difficult things about CO2 is it does take a lot longer, but everybody wants it to go faster, and it will get faster over time. As we get more AI involved, I'm sure you guys are working in the background on this stuff things will start to fine tune itself. It's going to happen. I see it already in our industry, but it takes a lot longer. So just remember, try not to rush it. I know you technicians out there are being pushed and pressured to get stuff up and running, but get the job done right the first time. I'll make your life so much easier.
For sure.
Chris, is there anything else you want to showcase on the software that will help any of the technicians out there watching?
You want to graph the high pressure, Chris? Let's graph just real quick. Let's graph the high pressure valve and the flash tank bypass valve together, just real quick. I want to see what this store's doing anyway. Yeah. So, yeah. See, we're still go back a day.
So take us through. So the people that are listening, the graphs are ranging from like the high pressures from 55 all the way down to 10.
No, that's percentage.
Sorry, the valves.
Yeah. So that valve's hunting a lot. So it's not real steady. It's not real dialed in. Shrink it up just a little bit, Chris, down there. I don't care what time frame. I just want to show them that you can shrink this up and get a little bit closer view. So, yeah. So see, we're hunting a lot on both. I mean, we're not real steady here. So, like if you flip it, during transcritical mode, summertime, we were probably a little bit better. So So like when you see stuff like this, my immediate thought is, okay, we need to get in here and check this out, because this is great, but it can be a lot better and a lot smoother. So anyways,
Yeah, no, because
but
the valve is
that's what
going
it is.
from 55% down to 0. You should, what would you say, like 10%? What are you looking for? 5% would be super tight.
Yeah, I mean, I look, to be honest with you, Trevor, I mean, controls is still going to have a lag in it. You're not going to get it just, I mean, streamlined perfect, but I look for, I don't want to see this. I don't want to see 25 to 35% way up there, way down, way up. I want to see 10%, 15. Sometimes you can get them, sometimes you can get them lower, but this to me is a little bit much of too much hunting going on. It's too much of, like you say, it's too much 55 and then all the way back down to 0, and then it finally steadies out for a minute and then it goes right back down, and so on and so forth. I would rather see that a lot more steady in between that 10 to 15 range.
So Cody, what would be a couple of things you would look at? So, because we know that if either one of these valves are hunting, is going to affect the other one. The air high pressure valves hunting is going to affect your flash gas bypass. What are a couple of things that, if you were going to go in and start looking at the store, what are some of the things that you would go and take a look at?
First thing, sensor placement. I guarantee it, the sensor on the gas cooler is not even by the gas cooler.
So you think that this temperature probe is not at the gas cooler, or you think it might be down on the rack?
Pretty sure of it.
Flash tank. Okay.
And then, yeah, and that's usually what's going to cause this type of issue, and so on and so forth. Because when it comes to our controller, sensor placement's important, because
100%.
that's how we're controlling a lot of things. So like I said, this store is going to need to be, in my opinion, looked at. But right now, I mean, it's running okay. But
the thing is too, is then so the placement of the sensors are so important. Then you got to think about the fan staging. Okay, is the fans banging on, ramping up or ramping down?
Yeah, we had that problem at this store.
And then another thing is that I would definitely check is that, was this set up in the middle of the summer? Was it also checked in the middle of the winter? Because they're going to run differently. So that's where the fine tuning needs to happen with these things. Because you set it up the first time when it's really warm out. We can do our best to simulate what is going to happen in the wintertime, or vice versa in the summertime. But you got to go in and check these CO2 stores in those times.
Oh yeah, 100%.
They're going to run different.
Yeah, awesome. Any final thoughts, guys?
I think I'm good.
Awesome. I really appreciate you guys taking the time. I learned so much today from you guys, and I want to dive in quite a bit more. I'm going to dive into that software. I'm going to check it out because I really like to learn more on the PLC side. I think that was the TDB software. I'm going to have this in the show notes, so people can, click on the show notes, go check out our RDM, our resourcedm.com. Very important. Once again, share this on your social media platforms, Instagram, LinkedIn, Facebook. This is how more people find out about the CO2 Mondays as well as RDM. Chris, Cody, I want to thank you so much for taking the time, and I really appreciate you guys doing this for me.
Oh yeah.
Yeah.
Thank you.
Thanks for having us.
Awesome, everyone. Have a great one, and we'll see you at the next CO2 Monday. Bye.
All right. Thank you.